Welcome to the CodeRIT Neural Nets talk. So we're going to learn how to build neural nets today. What are neural nets? What can you do with them? What can't you do with them? What's a good idea to use them for, all that kind of stuff. So has anybody heard of neural nets before? Yeah? What do you guys know about neural nets?
I know a library.
Huh?
I know a Node.js library, JavaScript library.
Okay. So like, what would you use neural nets for?
I mean, I like how to bring to map some instructions into the human brain.
Yeah. So like, they're basically modeled after how our brain works. Kind of like the neurons, the brain cells, basically. It tries to like create a structure, a virtual structure in the computer to map sort of like how our brain works. Any other terms, things you've heard about neural nets? What you use them for? Besides, like, don't Google it. That's not
Synaptic.
cool. Synapses. Synaptic.
Yeah.
Yeah, I mean, like, those are like kinds of. Oh, it's the library in JavaScript. Okay, yeah. Synapses are like part of the neural network system on our brains, not the artificial neural networks, which is what we're talking about in here. We're talking about artificial neural networks. Maybe should have been clearer on the definition that when we made the event. This is not a biology talk. If you showed up for a biology talk, that's too bad. You're in the wrong room. All right, so without further ado, I'm gonna like start writing or like describing a simple model of what neural networks are. Anyone taken like or intelligent systems? All right, cool. So this will be like the first time you see this. So basically, we'll start like today. We'll start with a very simple neuron model. We're not going to go like how to build like an entire neural network that classifies images like Google's TensorFlow or something like that. Yeah, we'll go with a very simple neuron model. So you have a neuron, have some inputs that go to this neuron, and then you have one output that goes out of that neuron. You can have also multiple outputs, but for now we'll stick with one. Or no, you can only have one output because, and we'll cover why. Yeah. So what do you think? Like, what do you think goes in? What do you think goes out?
Data.
Yeah, data goes in, data comes out. What sort of structure is that data? So you could have like as you can see from here, like this is like the input part, and then there is one output which is going to be a number, and inputs are also going to be numbers. Like everything else in computers, it's just binary digits, numbers. They eventually get turned to numbers. So we're going to have a bunch of numbers that go in. We're going to have some processing that goes on and some output that comes out of it. And what that output is, it's basically tells us whether some sort of property is fulfilled or not. So it's like an on and off switch, but the way that we're gonna look at it is not gonna be like a 0 or 1 output. It's gonna be a continuous line. So it could be anything between 0 and 1. But if it's really close to 0, if it's really close to 1, that means that our neuron is pretty sure that this output belongs to one class or another. So that keyword class there tells you that this is a classifier. Artificial neural networks are a type of classifier. So if you let's think of a very simple use of artificial neural networks would be classifying whether a given image is a cat or not a cat. So actually, let's look at a very simple example. Oops, I'll put this down. Okay, so let's look at images of cats. All right, so if I show you this, like, you guys are able to tell that this is what? A cat, right? How, like, what goes on in your brain that makes you believe that this is a cat? And if I give you this image, these are images of dogs for two reasons. One of them is because I wrote dogs, and the other one is because you can recognize what a dog looks like, right? Because you've been trained to be able to tell what a dog is and what it isn't, right? So it's kind of the idea behind neural networks. We want to have this really powerful model that we can train, and it will eventually learn certain patterns and be able to separate those patterns into classes. But this is all like very theoretical. How do we do this in code? The one more thing that we're going to cover in here in the board is that I want to like show you some sort of input, like just give you a simple example of how it actually works, and then we're going to go ahead and implement a very simple neural network, or just a simple neuron. So we said that a neural network is a type of classifier, right? So let's see. We got points that are x's over here, and we got points that are circles over here. All right. So how would you like classify any given point that or any other point that I give you in the future? Like let's say I see that there is this point over here. What would you most likely say that point will be, a circle or an X? Why do you think that?
The things around it are similar to a circle?
Yeah, the things around it are similar to a circle, and it looks like you can fit some sort of a line over here, right? Now, that's one of the simplest ways of classifying things. Neural networks are actually much more complicated, but this is kind of sort of the idea that we're going to go about it, to basically be able to imitate this behavior of this single line. The reason why we do this is because we don't want to complicate things too much. We want to keep them very simple, so everybody can understand like how to build the neural network, not necessarily why we would use it. That would be like more into the other talk, which is going to be fairly more complicated and using libraries that have already built in what we're going to write today. So this is kind of like just giving you a general overview of like how neural networks work, like at a very simple level. All right, so if I gave you this point over here, you would say that's most likely going to be a circle. So how do we build a neural network that will be able to tell us that? Well, first thing, we need to know what the input is going to be. And what is the input in this case? That I said it's going to be a point in the coordinate system. So what's the input going to be? Yeah, so it's going to be basically an X and Y value. And if it was a three-dimensional a three-dimensional system, like we would have X, Y, and Z, and so on. If we extend to images, you basically have all of the pixels as part of your, like the number of pixels, basically the number of your dimensions. So that's the input. In this case, we're going to have an array with XY value. I like to go with arrays because you're not gonna change the input values, but just for simplicity in Python, like we're gonna be using Python to implement this. Hey. So all right, so we got this. This will be our input. So our neuron will be a very simple neuron that takes an X and a Y value. And it will provide some output, right? So the output's going to be whether this given XY point is above or below the line. So let's say it's going to return 0 if it's above the line, and it's going to return 1 if it's below the line. All right, or vice versa. It doesn't matter really. Eventually, like you're gonna, pick your own numbers for that. But we want it to be a number between 0 and 1, so that it's kind of like normalized, and we can compare it to other outputs if we decide to make our neural net more complicated. Yeah. So, but how does this neuron learn? Like, where is it gonna learn? And we're only dealing with numbers. So the way that this works is that for this input array, aka vector, we can multiply this with a weight vector. And a weight vector is a simpler way of thinking of the weight vector is by looking at these input synapses, basically as them having weights. So basically we're going to multiply this X value and this Y value with Wx, which is the weight for the X synapse, and the weight for the Y synapse. All right? And that's going to give us, if we multiply X by Wx and we add that to Y times Wy, we're going to get some sort of sum. So we're just going to call this the sum, okay? Another way of writing this is I equals 0, and then or size of the array, of the input array, and then you do or input, I already used that. So I'll just do AI times weight I. This is another way of saying this, right? And yet another way of saying that is by doing matrix multiplication. So you're going to have this matrix slash vector slash array slash tuple, whatever you want to use, times this. Transpose, because of vector properties, you can't multiply. Yeah. But let's stick with this one, right? That's the simpler way of doing things. We'll stick with this because we can see how this actually works. And how are we going to pick these weights? Any ideas? In other words, the baby is just born, and its neurons like have absolutely no idea of what's going on in the world. Why is that?
There's no perception of it.
Yeah, and we actually should not pick in a biased way any sort of weights because that's. Yep. Question.
I was going to say
Yeah, it doesn't have experience yet. And another very strong use of neural networks would be to understand something that we don't as humans necessarily. So like you don't want to have any preconceived bias. And by picking weights, you're basically being racist when building an artificial neural network. Yeah, you don't want to do that, okay? We go with random weights. Just build random weights and you're good.
How do you choose the random weights?
So just do Python random.random.
This is always some for a bias. How do you control it? It's okay.
Yeah, that's a whole topic, but Python random is good enough. We'll stick with that. All right, so yeah, now we have this sum here, and what do we do with that? How does that sum get turned into an output that's 0 or 1 or anywhere in between? Any ideas?
Sorry, can you repeat the question again?
So we got this sum, and these weights could be anything, like I've seen weights be like anything from like negative a lot
Sorry,
to...
what's the variables again before the sum that's adding up to the sum?
So this is x times the weight of x, of the x synapse,
Oh, so the
plus
weights are
y times... Huh?
So the weights are random numbers that we're choosing.
Yeah.
Okay.
And x and y are inputs that are given to the neuron.
So would it become 0 when, the arguments that are passed in, it's like completely balanced, and then 1 if it's like completely unbalanced?
Well, not necessarily.
Like 0 or 1, but you know what I mean. Like there's like an average, and the average is either like biased or dissented.
Yeah, not necessarily. It really depends on the sort of case that, but it could be. I don't think so though. Like I could see some cases that wouldn't work. But that's a good shot.
Wait, so do you keep running it until it reaches?
We haven't gotten there yet. We haven't gotten there yet. So yeah, any ideas how we turned this sum? Like imagine this weight could be like 800, and this weight could be like negative 200, and this input could be like 1, and this input can be 2. And you're gonna have 800 minus 400. So like this sum is gonna be 400. So how do we turn that into a number that's between 0 and 1? So the way that people that do machine learning do it is using this thing called a sigmoid function. Whoops. All right. So just to give you a better idea of like how the sigmoid function works, Wikipedia is always the best place to go. So there's this formula which is fairly simple if you think about it. We know what 1 is, we know what the other one is, we know what E is, and you put it on the power of negative t. E is just our sum over here. Okay, so that's gonna kind of normalize our sum to be anything between 0 and 1. Or something between 0 and 1, rather. Okay, cool. So we got the sigmoid function over here. Let's see. Oops. All right, so we got the sigmoid function that takes in the sum. So it's going to be 1 over 1 plus e to the negative sum. Right? And that's going to provide the output. Now, how do we make this neuron learn? That's the most important part, because so far we've just picking random stuff. We haven't really made it learn anything.
Trial and error. It's one way.
Yeah, it's kind of, yeah. Trial and error is one way to do it, and the actual way it's done, it's like very close to trial and error. So basically, we train this neuron by providing it some inputs which we know the outputs for. This is what all data mining and machine learning calls training. Training is basically marked data that's that we know it's good or bad, or a cat or a dog or whatever. We're gonna have some inputs. Let's go back to the case of 1, 2, right? This is gonna calculate the sum 400, and it's gonna put 400 into this function, and some output's gonna come out of there. And we know what the output should be, right? So like we know it should be either 1 or 0, and what we do is we create this training function that's gonna calculate the difference between the desired output and the actual output. And then it's gonna go back over here and readjust these weights based on that result. So if it's 2 off, it's gonna readjust the weights accordingly. If it's a little off, it's still going to readjust the weights accordingly. And we're going to see how that's done in code. I'd rather not write more stuff in here because it's getting really clogged and hopefully not too confusing yet. Yeah. So if you have your laptop and if you know Python or any other language, just try and follow along. It's really, yeah.
I just want to know, when do you apply the sigmoid function?
So you apply the sigmoid function as soon as you calculate the sum.
Okay.
So that negative t on the sigmoid function is basically the sum, negative sum.
Okay.
All right, so let me just switch this to screen share. Okay, cool. So I'm gonna make a new Python script. All right. What I want to do is create a neuron class. That's our basic construct, right? And during object-oriented programming, sorry about that. But I think it makes sense, you know. And just like with other classes, you need to have a constructor. So we're going to have a constructor. And what should we pass into the constructor? What do you guys think? So the weights are going to be picked at random, but that's very close to like what I'm actually looking for. That's the input, so that's going to be passed multiple times into the same neuron. So we don't want to do that in the constructor yet, if that makes sense. Yeah.
The value of the neuron, like 0 or 1?
That's always going to be like 0 or 1, like between 0 or 1. So like that's what we're trying to get at. Any other ideas? Go for it. All right.
The inputs or the
Yeah, the inputs, the number of inputs. That's the actual. So we want to know how big the input array is going to be. That way we know that how many weights we need to pick. Because if we pick, oh, I deleted that. But so if we pick like 5 weights and we only have 2 different inputs, that doesn't really make sense to multiply those 2 matrices, right? We're gonna have like math errors all over, especially if you're using NumPy. So yeah, we're gonna need to know the size. So I guess like you can give each neuron a size. And we're gonna add some stuff to this later, so like if we have time. So yeah, we want to create a weights array. Weights. Yeah. I'm pretty sure like you have to make the.
Control the box or something.
Nope. Wait, I think like you have to go to font and stuff. Like, can you guys in the back see at all?
I'm gonna tarp on to it from here.
Yeah.
All right. Options. Oh yeah, that's where it is. Yeah. Better.
Better, much
Yeah,
better.
that's awesome.
Awesome. Cool. All right. So yeah, self.weights. We want to create a new array. And we want to iterate for I in range size. We want to append a random. We want to append a random weight. So we're going to have to import random. So we're going to have to do here self.weights append random.random. Feel free to correct me if I'm wrong. It's been a bit since I've last written something like this. Yeah. And I think for now that should do it. Right? Cool. So that's our constructor. Any questions so far? Everybody good? Cool. And that process where you provide the input is usually called the feed forward. So we're going to have a function which is going to be called enough feed forward. Actually, let's go with Python notation. Yay. And we're going to have an input array, right? We can't do that in Python. In array. Actually, before we even do this, let's make sure that, test every step. So I wanna be able to see what I currently have in my neuron, right? So I'm gonna write an str function. It's basically the Java version of toString. If you're not familiar with this, Python has a bit of a weird notation when it comes to class making. So just bear with me. And I'm gonna do actually return self str self.weights. And if I run this, and I create n as a neuron, bad idea. Neuron, and I need a size. So size, I'll say 2. And if I do str, so these are the random weights it picked. Fair enough. We're printing out what weights are currently in the neuron. And we're gonna use this str function because we're gonna compare the neuron before we train it and after we train it. Does that make sense? So we can see like what the difference in weights is. So I'm gonna minimize that. All right, on to feed forward. So remember again, we had basically a sum of all inputs times each weight. So every input is associated with one weight, and we multiply them all and we sum them, right? So we're going to have this result, which is basically the sum, but in Python, if you write sum, guess what? It's a function that's built in, which it's cool, but it sucks sometimes. So the result is going to be the sum of, or actually, let's do this out, and then I'm going to show you a shorthand notation in Python to do it. So for I in, all right, let's go with this. For index item in enumerate in array. Anyone know what the enumerate function does?
Doesn't it map the index of the actual value in your array?
Yeah, so it gives you basically a tuple. Let's not have a fight. Yeah, it gives you a tuple, or of indices and items, each of them kind of paired up. Does that make sense? So this is like a quick way of doing for I in range of length of input array. This is the non-ghetto way of doing it. Yeah, so we're going to have a result equal to 0 over here, and I'm going to have result plus equals in array, or sorry, item times self dot weights of index. Does that make sense?
Can you explain the first method again, real quick?
Which one?
Init.
Oh, this is the constructor. So in Python, init is the constructor.
There's Node.js, so I'm trying to map it, right?
Yeah, that's totally fine. So yeah, init is just the constructor, and you pass in a size. Self is just a self-reference. Like every function that belongs to a class in Python needs to have that self keyword, so you can use it to refer to yourself, basically.
And so instead of self.weights equals empty brackets, I would put just weights, bar weights equals empty brackets.
So in another language, you would have something like this, like array, whatever, double in this case, because weights are doubles. You would have like double weights outside the constructor, and then inside the constructor, you would go like weights equals new weights. Yeah. So it's a class variable basically. Just a warning, if you're doing this in Java, it will look really ugly. But that's just my preference. What do I know?
So what, you're gonna Oh, nothing, I thought you transcribed, no.
So at the end, like I have all this stuff on my GitHub, and there is a Java implementation as well, and we're gonna check it out later. Okay, so here's what we have, right? And then we're gonna pass this into the sigmoid function. Now, I really can't stand having like for loops without like doing list comprehensions, because that's why we're using Python, huh? Well, yeah, I should have. It's a good point. But like for this will make it easier. Like, just check this out. You could do a result sum of some array, and this array is going to be basically all of our inputs and our outputs, or inputs and weights multiplied together. Okay, so we're going to have in can't use the keyword in for element or item times weight for item weight in zip self or not self that way in array and self dot weights. So we can use the zip function here because we know that the weights array is the same length as our inputs array. Does that make sense? And the zip function basically gives you all pairs. Like it's really cool because it builds like this array of tuples with one element from one array and one element from the other array, and it pairs them up. So it's really awesome, and you can do all this in one line. Frankly, it's longer, but it's cooler. So why not? Yeah. So this is our result from the first process. Remember, we had inputs coming in, and here is where we apply the sigmoid function. Here is where we have weights, and here's where we have inputs. Right? So we're done with this process here. We're done with this here. Do the sigmoid function, right? To kind of get the output. All right. So we're gonna pass this just to keep things neat. We're gonna return activate, and we're gonna pass this result. And what that means is that we're gonna have to write the function called activate. And any idea where we're keeping these separate? Just take a guess. Why are we not doing the summation and the activation in the same function? Software engineering majors, anyone in the house?
We'll do it again. Release activate twice. Or...
Yeah, it's like coupling and cohesion and all that stuff, right? The major reason is that you can have functions other than the sigmoid function. So like you can use the hyperbolic tangent function. You can use other sort of functions that give you values between 0, 1, -1, and 1, all that kind of stuff. So that's why we like to keep them separate. So if you eventually decide that you don't like the sigmoid function anymore because it's so boring or it's so complicated, then you can just go with another function. You can actually use a linear function. That's not a neuron that will do much, but you can use it. Yeah, it will. Good point. Thanks for pointing that out. So yeah, self.activate because it's a function that's in the class. All right, so here we're going to return 1 over, actually for activate, we don't need self because we're just passing values. So we're going to return 1 over 1 plus e, that's not the Python way, to the negative result. You're right, math.e. Import math. I have to do math.e. Let's see if, I just hope this won't crash. Oh, it did. So it's math lowercase. So. I'm pretty sure Python has math built in. Yeah, there you go. So n equals neuron. Did that twice today. And I'm gonna give it a size of 2. And let's see, str n. So it's getting built. And if we call feed forward n dot feed forward on some input array 1, 2. So yeah, our something here went wrong. We need self comma. Let's try all this again. Value. Sorry about that. Yeah, there we go. So this is what it returns basically. I don't know if you guys ever saw, but like there were these 2 guys at RIT last year that built this neural network that would play Super Mario. And at first it was absolutely bad, like at everything. And this is exactly what's happening in here right now. Like it's bad at being able to tell what we want it to do, right? Yeah, sorry. Right, so we're good up to here. Now we gotta be able to train it, right? We gotta be able to change those weights so we can make our neuron learn. And kind of going a lot over time here, but I'll try and wrap this up. We're gonna have this function called train, and we're gonna have an input array, and we're also gonna have a desired output. So this way we tell our neural network that, or neuron in this case, that this is the value that we want, and compare it to what you got and adjust yourself. All right, so I'm gonna cheat for this part, and I'm gonna go. All right, so if you go to my GitHub, basically there is ANN, artificial neural networks, which is in Java, and there is PyNNN, which is in Python. That's the equivalent implementation in Python. It's fairly, it's a bit more complicated, I think. There's bias values, which we're not going to cover. Yeah, your neural network is going to crash eventually because of this sigmoid function. So if you use my implementation, I've kind of like studied what the maximum value that e to the power of something could be, and like I've put like breaks for those basically, like so it doesn't go over that given. Yeah, it's okay. Here, I'm just gonna copy this code and explain it over here.
What's your?
It's OXHAGOLLI.
OXHAG.
It's up there in the link if you. I don't know if you can see it. Yeah. I'll put it on links on Facebook. So if you're in the Facebook event, I'll put links for this. Okay, cool. So all right. So we calculate this output variable, which is basically what our current neuron generates given the input. All right, and then we calculate the error value, which is value that we want minus the output that we get. And then what this does is basically, I'm going to get rid of this alpha because we haven't introduced what alpha is. What this line here does is it goes through all of these weights that we have, and it adjusts them by the error rate. And you're going to get, as of now, probably a worse result. Because of the error rate. it might over adjust. So let's see what we have right now actually. Remember what we're trying to do is that we have this graph and we have this line, and we want everything that's above this line to be, so everything that's over here is a 1, everything that's over here is a 0, or vice versa, it doesn't matter. Okay, so how do we train that? We're gonna create a new neuron of size 2. And we're gonna do a loop for I in range. How many data points do we want? Let's go with 10,000. So we're gonna train it with 10,000 data points, all right? And let's pick random data points so they're not too big and our program doesn't crash. So we're gonna have random.random xy equals random.random, comma, random.random. All right, so those are going to be our xy values, and we calculate by ourselves basically if y is bigger than the x value, then we should return 1. Otherwise, we should return 0. Does that make sense? This is line y equals x, right? So, yeah, there are a bunch of examples. If you go towards the end, like there are a bunch of examples of how to train it, and how to make this bigger. Whoops, it's too big. There's so this is example training, and this is examples of like how well it was trained. So we're going to do something like what we're going to do something like that over here, or actually no, in the running thing. Yep. So we're going to set desired value equals to 0 by default, but if y is bigger than x, we're going to set desired equals 1. Does that make sense? Because that's our desired value. And we're going to do n.train on x, y, and desired. Okay. Yep. Iterate. Yep. And over here too. If you like mess up, you can just like click on there and it'll just copy the line. So there we go. It's trained now. And if I do, or it's trained in 10,000 data points doesn't mean that it's accurate. But let's see how it does. So I'm going to do str of n, and those are the weights that are currently there. All right. Cool. So let's try n.feed forward of let's try what let's try 1, 2. What should that return? What should 1, 2 return? Yeah, because it's above the line. The y value is bigger than the x value. Yep. Yep, you're right. I did that. Here we go. It's a value very close to 1, right? So yay, we taught a neuron. And if we do the opposite, 1, 0, it's 7.8 times 10 to the negative 13, very close to 0, right? So we can say with very high certainty that it's very close to 0. Now, if we try 1, 1, it should be something that's fairly close to 0.5, and it's fairly close to 0.5. So yeah, congratulations if you were following along, if you built your first neuron. I'm gonna go over something very simple just to like increase the accuracy of the neural network. There are a billion things that you can do to increase the accuracy, including biases, and not the bias that we talked about. It's a different sort of bias, a separate input. But the one thing that's really important is in your constructor, you should add an alpha constant, which is basically a learning constant that it's going to use. So when it does train here, it kind of moves more incrementally versus like jumping around from positive to negative value. And I know like this is probably like way too much right now to take in all at once, but just like putting it out there if you're interested. So self.alpha equals alpha, and down here we're gonna multiply this by self.alpha. This will increase the accuracy of the network. And if you don't believe me, why don't we try it? Oh, too bad we deleted that. I'm just, yeah. It's kind of like almost 9, so I'm gonna let you guys try this on your own. But I'm gonna post the link on Slack on the Facebook event. If you guys are interested, follow along there. Any questions, anything, just message me on Slack, Facebook, or start an issue on GitHub, anything like that. All right, thanks. The other thing we're going to do is, how many of you tried the puzzle last week? Anybody? No? All right, anyone interested in knowing what the puzzle is, how you can solve it? All right, cool. Yeah, thanks for coming then. The puzzle for this week will be probably posted sometime this weekend, so keep an eye out for that. Slack. It's usually on Slack. Yeah. Yeah. Thanks for coming, everybody. Try and build practice with neural nets and impress people tomorrow. I'm not sure.
It's okay.
Huh? Yeah.